homework for 9.5. I did copy this for you guys, so you shouldn't have to be writing as much on this one. Except this says express this as a sum of logarithms. So they put it together as a multiplication. Multiplication goes with what? Addition. I mean, you need to put this in your brain. You're going to go back and forth from multiplication to addition, and you're going to go from division back and forth to subtraction. That's what you're going to call, like, okay, I've got a subtraction. That means that's going to be division. I've got a division. That means that's going to be a subtraction. You need to have that in your brain. So we've got a multiplication. So that means that we are, when we separate them apart, we're going to add And this is another thing that's kind of challenging about the homework card is how simplified do they want you to get? And they don't want you to do anything else to that problem. That's what they want the answer to be. Log base 14 of 14. I do know that this is one, and if you haven't done the homework on this yet, you probably haven't practiced this enough. But if these two numbers are the same, log base 14 of 14 is 1. We're going to come into that in a minute, but they don't want us to simplify it. They want us to stretch it out. That's the answer. These are being multiplied. D times F. So that means when I stretch this back out, multiplication goes with addition. That's it. This one, they're saying write this as a product. Well, all this is we don't really need those parentheses. So they're just asking us to move the 19 in the front. So it would be 19 log base big N. Be careful about that little x is the answer. Yeah, if you type in a little n, it's going to say wrong. So type in whatever they're putting there. Remember that when we were doing this problem, we said that if you had something that is like x to the third, or the cube root of x is the same thing as x to the third. I remember that. So that's what they're using right here. They're saying, oh, this is the natural log of 7 to the 1/3. So we're going to move the 1/3 to the front. That's going to be the natural log of 7. Everybody okay with that? This is division. Division means you're going to do what? Subtract log base C of big B minus the log base C of 8. And it is important that if it has like the bases, you have to put those. It should be the same for both things. So we're stretching it out. We have another division. Division goes with subtraction. So we're stretching that out. The natural log of S, not 5, minus the natural log of N. Not bad, right? So far, I hope. Okay. Rewrite as sums or differences of logarithms. I am multiplying x to the 9th times y to the 5th times z. So I'm multiplying all of those, and multiplication goes with addition. So when I stretch this back out, it would be the natural log of x to the 9th plus natural log of y to the 5th plus the natural log of z. There's one more thing I need to do. That power rule where if we've got an exponent, you move it to the front. So the final answer would be 9 times the natural log of x plus 5 times the natural log of y plus the natural log of z. Okay, now we're kind of getting to the problems we had as examples. We got two things going on here. We're multiplying on the top, we're multiplying again on the bottom, and in the middle, we're dividing. So when we write this, we want to write it as, okay, we're multiplying on the top, so that's going to be an addition. Then we're dividing by something, that's a subtraction. Then we're multiplying by something again on the bottom. So the log base B is going to be every one of these. On the top, we've got a P to the 4th and a Q to the 6th. On the bottom, we've got an M to the 3rd and a B to the 7th. Please don't feel like you have to write all these steps, because some of you are going to catch on a little bit faster, but I want to make sure I'm writing all the steps so that I have somebody that is confused. This might help them. Also, those of you who are following on Zoom, I imagine that it's hard to copy this down this fast, but I am going to post this video if you need to go back and look at it. You can fast forward it to whatever problem you need to look at. So I've distributed that negative to both of these things, but other than that, I got rid of the parentheses. I need to get these powers in the front too. So that would be a 4 log base B of P. 6 would come in the front. Log base B of Q. The 3 would be minus 3 log base B of M. 7 minus 7 log base B of B. Okay, this is important right here. And I probably am not going to rewrite the whole thing here, but this, when these two things are the same, this whole thing turns into what? 1. Because what you're saying is B to what power would give you back B? If you use those things that we've been talking about, expressing it as an exponent, B to the first power is B. So that's why the answer is 1 if these two numbers are the same. So this right here is just going to be -7 times 1. And so that's why the right answer is what? C? Okay. Because that whole log base B of B just turns into 1, and -7 times 1 is just -7. Okay. This one, there's nothing being multiplied on the top. So we've got one thing on the top. We've got a division next, so that's a subtraction. And on the bottom, we're multiplying 3 things. We're multiplying 8. We're multiplying x to the 8 times a y. So we need 3 spots for things being multiplied on the bottom. So the natural log of 5 minus, because we're dividing, the natural log of 8, the natural log of x to the 8, and we're also multiplying that by the natural log of y. Okay, not really anything I can do there's nothing in front of that parentheses to simplify, but this minus needs to go with every one of these. And if y'all are ready, I'm going to move this 8 in the front when I do that too, right? So minus natural log of 8. Minus 8 natural log of x, because I moved the 8 in the front and I distributed the negative. Minus natural log of y. That would be the answer to that one. Okay. When you see a square root of x and there's no number up here, that means that that number is a 2. So you could rewrite that as x to the 1/2. That's the first thing we're going to have to do. We've got the log of b to the 7th c, because we can't really, as long as it's under the square root, we can't really do anything to that. It's raised to the 1/2 power because we're taking the square root of it. With the properties of logarithms that we just got through using, well, there's a couple things we could do with this. Let's back up. Let me think about the best. This is one of those where there's more than one right way to work with a problem. What's the best way for you guys to think about it? And I think I'm going to go with what I was saying. So the 1/2 could go with both of them. So we could say, well, that's the log of 7 times 1/2 would be 7/2. 7 times 1/2. And then c to the 1/2, if we put them with both of those. We are multiplying, which means we do what? Add B to the 7/2 plus the log of C to the 1/2. There's one thing left. If they're raised to an exponent, you got to move that exponent in the front. So that would be 7/2 log B plus 1/2 log C. That's the answer to that one. Doesn't this one look fun? Does to me, but I know it doesn't to y'all. Okay. So this one is probably the most difficult. After this one, they're going to speed. This is going to speed up a lot, I promise. The last ones are putting things back together and they go pretty quickly after that, after this one right here, number 11. So if I have something, and this is a 4 out here, this means that if I've got the 4th root of x, I could write it as x to the 1/4. So that's the first thing. I can't mess with this thing as long as it's under that radical square root sign. I can't do anything with it. So I'm going to say m to the 12th, n to the 20th, c to the 5th, a to the 5th, but I'm going to say, well, that's all raised to the 1/4 because it's the 4th root. This 1/4 needs to go with each one of these things, which is why in support it started having you work with these properties of exponents so you'd be able to do this stuff. So you're going to say m to the 12 times 1/4, n to the 20th times 1/4, c to the 5th times 1/4, a to the 5th times 1/4. So we're taking that 1/4 and putting it with every single thing. Well, a 4th of 12, so m to the 12 times 1/4, a 4th of 12 is just 3. A 4th of 20, so n to the 20 times 1/4, that would be 5. 20 times 1/4 is 5. On the bottom, it's not so nice. C to the 5 times 1/4 is still going to be 5/4. And a to the 5 times 1/4 is 5/4. At least we've cleaned it up a little bit, but not great. So I'm multiplying two things on the top. I'm then dividing. I'm multiplying two things on the bottom. So addition, subtraction, addition. So this is that where you go, hey, I'm multiplying two things on the top, then I'm going to divide. So I'm going to subtract two things on the bottom. So the log base c of m to the 3rd, the log base c of n to the 5th. So I took care of the top because they're being multiplied. I'm then dividing, so that's why the subtraction that is there. Log base c of c to the 5/4, the log base c of a to the 5/4. Everybody okay with that? I can move the 3 down front, so 3 log base c of m. Can move the 5, and there's nothing in front of these parentheses, so I could just get rid of that parentheses. I don't need that there anymore. So plus 5 log base c of n. Just use the power rule. This negative needs to go with both of these. It needs to go with this, and it needs to go with this. So I know I'm having a minus and a minus. The 5/4 can come in the front, log base c of c. And this 5/4 can come in the front, log base a c of a. There's one more thing. What is it? This, yes. This right here, this are the same. So that means this whole thing is 1. So my final answer on this one is 3 log base C of M plus 5 log base C of N minus 5/4, because this is 5/4 times 1 minus 5/4 log base C of A. Okay, that's the most challenging one there, definitely. We are adding, who needs me to slow down? Calvin, you almost there? You're good? Okay, we're adding, so we are multiplying. So this all you do on this one is go, what is the log base B of 76 times 54? Which is going to be the log base B of 4,104. That's the answer. But that's all you do on that one. Just you put them back together. We are subtracting, which means that we divide. So the log of 10,000 divided by 1,000. Okay, you could actually do this one in your calculator, but 10,000 divided by 1,000 is going to give you 10. So this would be a 10, and the answer to that is going to be 1, because this is a base of 10 and those numbers are the same. So this answer turns out to be 1. Good with that? Okay. They're wanting me to put these back together. So I see an addition. Addition means that I'm going to multiply something. I see a subtraction, which means I'm going to divide by something. So the first thing I would do is probably put these back up where they go. So log base C of x to the 1/3, and then plus the log base C of y to the 3rd, minus the log base C of x to the 5th. I've just put those exponents back where they go. They're all log base C's. I'm adding, so that means I'm going to multiply the 1/3 and the y to the 3rd, because there's an addition. And then it says divide by x to the 5th. Is everybody okay with that? So this was our multiplication. This is our division. You can't, just like you can't have, if you wrote 5/10 on a test, I would be disappointed if that was your answer. Okay. Because I would be like, come on, you know that is really 1/2. You would reduce that. That's the acceptable answer, right? You can't have variables that are the same over each other. You have to reduce them. Just like if you had x squared times x to the 3rd, I would expect you to put those together. So on this problem, the property is, if you're dividing and they're the same, that you subtract. So x to the 1/3 minus 5. The y didn't have anything. I don't know why I wrote a 5th there. It's supposed to be a 3rd, sorry. So I would say, okay, either in my calculator or my brain, 1/3 minus 5, it ends up being -14/3. If you subtract 1/3 minus 5, can we have a negative exponent? It would move to the bottom of the fraction. So I know this is a tough one. That's why I wanted to break this down so much. So our final answer is this. But you got to get rid of that negative exponent. It should move to the bottom of the fraction if it's on the top. Okay, I see a subtraction, which means that's going to be a division. They're both natural logs. This 5 probably needs to come back up here. So natural log of x to the 6, let's look at what that would look like first. minus if I move that 5 back up. Right now, this thing right here is x squared, and then it's to the 5th, or we're taking the 5th root of it, which would be a 1/5. And if I move the 5 back up there, we have something else. We had a 5. Okay, so the x squared, I wrote that down. The 1/5 came from the fact that this was a 5th root of that. And then the 5 came from the 5 being in the front. So I knew I had to move it back up. So before I even do anything else, I'm gonna figure out, well, what's all that stuff? So the natural log of x to the 6 minus the natural log of x. All I have to do is type in 2 times 1/5 times 5. And luckily it just is 2. Because the 1/5 times 5 is just 1. That kind of cancels each other out. Now this is easy. I've got the natural log. I'm dividing, so I am, I'm sorry, I'm subtracting, so I'm dividing. We do need to simplify that, because so we would subtract and say, what is 6 minus 2? That's not negative. So we can just, that's it, x to the 4th. On this one, we are subtracting, so we are dividing. They're asking you on this problem to factor this thing to see if anything will cancel out. The bottom's done. I need to factor the top, so we could use the quad program and factor. If you use the quad program, you would get your zero, you would get zeros for that, and it would tell you that your zeros are -10 and -3, and you would do the opposite, right? Well, the 10s are going to go, the x plus 10s are going to go away, and we're just going to get the natural log of x plus 3. Same thing on this one, we are subtracting. So we are dividing. Right, however you want to factor this. Could use the quad program again on both of these, that would work. I'm saying what multiplies to -12 and adds to 4. So x plus 4, x minus 3, and on the bottom, that's the difference of squares. So it'd be x minus 4, x plus 4. These will cancel. So my final answer is log of x minus 3 over x minus 4. So I hope that I did not completely bore you to death